Alternating currents in electrical circuits. An alternating current is the flow of charge that changes periodically in a circuit. As current can change direction, voltage can also change polarity, reversing from positive to negative over time. A basic AC circuit is shown on the right, where you can see one period of the sine wave inside the source. An alternating current can be represented by the equation below, where Vt is the voltage as a function of time, Vp is the amplitude of the sine wave, which describes the maximum voltage, either negative or positive, F is the frequency of the waveform, or the inverse of the period, T is time, and phi is the phase of the sine wave, which is how shifted the wave is with respect to time. Some examples of the mathematics used in AC circuitry can include impedance, both series and parallel, Ohm's law, inductive reactance, capacitive reactance, and RMS voltage. There are several examples of the mathematics taught in MATH141 and 142 to be found within AC circuits, such as the use of vector addition and complex numbers when examining a circuit with multiple AC sources. In this diagram, we can see that we have three AC sources, all with different magnitudes and phase angles. By adding the vectors graphically, we can visualize the resultant vector, which is the sum of the three. To determine its magnitude, we use the complex number j, which is the square root of -1. The polar form of this result equates to 36.8 volts at an angle of -20.5 degrees. Home and office outlets almost always use an alternating current, since the generation and long-distance transmission is significantly easier than that of DC. AC electricity can be converted to high voltages easily with the use of transformers, which is crucial as a high voltage means far less energy lost when stretching long distances. AC is also compatible with electric motors to turn electrical energy into kinetic energy for a whole range of applications. The opposite can thus also be achieved, and kinetic energy can be turned into electrical through the use of a generator. AC generators, motors, and distribution systems are far more efficient than those of DC, and so are predominantly used throughout the world. AC generators can be found anywhere, from the colossal power stations that power entire cities, to a bicycle-mounted generator that uses the wheel's kinetic energy to power a small light bulb. Thanks for watching.